Large number of people, a little bit less than I'm used to, but never mind. This is basically a repeat presentation. If you were at the tutorial on Monday, you've probably already seen the bulk of these slides, but lots of good information. So let's get started. Little bit of, well, large number of slides to get through. Hopefully I'll manage to get them all in. Okay, you can't see the slides, but hopefully there we go. So a very fast introduction about myself. My name is Ritchie. I work for Zend Technologies. I've done for apparently 6 years. It doesn't feel that long, but I was told yesterday that I've been working for them for 6 years. Background, I'm an engineer, but I've done a lot of system administration and PHP development. I'll leave it at that because we're going to need a lot of time to get through the slides. But basically, I've seen performance problems from both sides. So I've dealt with them as a developer and also a sysop. So I've got reasonable amount of experience of fighting performance issues. Because I'm a consultant and go on site, I do tend to work a lot with customers, and because of that, see their performance problems too. So this presentation is more or less a summary of 6 years of work. So what we're going to be looking at today, just it's going to be a very quick spin through a definition of what normally causes performance problems within a PHP application, not necessarily related to PHP, but generally applications in general. We're going to be looking at the tools that I use personally to solve those problems. Of course, they're not the only tools that exist, but in my opinion are very powerful tools. We're going to be looking at basically how to put off work to make your application server look more performant than it actually is. So marketing for your web server. We're going to be looking at various different ways of caching, in actual point of fact. So the best way to accelerate your application is to have it not work so hard. So you don't want to do things repetitively. You're wanting to use a bit of caching. Well, we're not going to be covering quite a large number of things, unfortunately, because we only got so much time. But of course, these are all perfectly valid ways of increasing the performance of an application server, irrespective of its architecture. But these are things which I do have a little bit of experience on as well. Of course, I deal with them day to day, but they're just not going to be in this talk for reasons of time, unfortunately. So let's start off with definition of our problem. We usually end up in such a situation. We've developed a new website, we've put it live, everything's going great, or at least we hope it is. We've got no bugs and otherwise problems, and we've started to sign up users. Our users have started to be attracted to our website. It's very popular, it's something that's going down well with the general public, and we end up with more and more people joining our application through word of mouth or through advertising or whatever. Eventually, that number becomes greater and greater. And then all of a sudden, from one day to the next, that happens. The web server, which was doing just fine the day before, just falls over. And that's actually, unfortunately, quite common because there's usually something in your architecture which will reach its limit, and then the whole thing will break down. So the first thing that we have to do is identify what that problem is. It could be anything. There are a large number of various different reasons for a performance problem. And of course, we've got a large number of tools that we can use. We all have our own favorites. Of course, some people tend to work with relatively basic tools. But if you happen to be lucky enough to have Zend Server or some other monitoring system installed on your web server, you may be able to use event monitoring or some other type of tool, log analysis, which will be able to tell you which components of your application are just running slowly, and you can deduce from that what's actually the problem. Some people go to relatively extreme levels of effectively putting in micro times in their application. It's not the best way to go. In my experience, you're going to get the best mileage from using a very complete tool, and code tracing is one of those. So the Zend code tracing is one of the features of Zend Server. So let's talk a little bit about that first. That's what it's going to look like. If you've been watching the keynote at the start of the conference, you'll have seen this view very briefly. It flashed across the screen very quickly. It's difficult really to get an impression of what code tracing is just by looking at the screen, because it doesn't mean anything to you unless it's your application. But the number of times that I've gone on site and I've been faced with a completely new application. This is potentially 200,000 lines of code that I've never seen before in my life. And there's in there somewhere a performance problem. And it could be 10 of those lines which are causing the problem. It actually is quite often the case. There's just 10 lines of code. You can use this to learn an application in half a day. Not, of course, to the point where you could continue to develop it, but to the point where you can isolate a problem. So if you're ending up supporting a code base that is a legacy, not being written by you, you know there's a performance problem in there and you can't find it. This is your tool. Now, there are two views in code tracing. Just show you the other one just for the sake of completion. But this is actually the view that I use most often to find performance problems, because what you'll get here is a list of functions which are being called by that application. There could be hundreds of these, or even thousands. And what this allows you to do is sort by time. You can sort by a frequency that functions are being called. And it might be the case that very, very fast function calls are actually the ones that are the issue, because just the volume of them, it can be very, very hard to track these down unless you're using such a tool. If you actually have code tracing installed, this is the best way to actually generate a code trace, if you have the permission to do it. Just add dump data to the end of your URL line, and you'll collect a code trace. So if you know that there's a performance problem in a specific piece of code, and you have access to the server, then you can just throw this onto the end of the URL. You'll collect a code trace. You can start to actually use it. The official way, of course, if you don't have direct access to the machine, you would have to use this. You can use event monitoring and configure that event monitoring will trigger a code trace. So when something bad happens on your system, then you can collect the information that you need to solve it. And really, like Andy said at the start of the conference, code tracing is pretty much black box for your PHP. So really, everything that goes on through your server is saved into that code trace, and you really don't have to replicate the problem. So like in an airplane, you don't really want to crash 10 aircraft when you've had one go down, because that's a very expensive way to do things and actually quite dangerous for the pilots. What you want to do is to be able to look at the wreckage, so to speak, of the PHP application and try and diagnose what the issue was. So that's code tracing. Once you know where the problem is, and usually this will help, code tracing will help you find it, the next thing that you're wanting to do is to solve that problem. The thing that most people tend to turn to, and sometimes it's a bit abused, which is why these slides I've cut out of another presentation, is to use caching. There are a variety of different ways of using caching. If you were at the keynote just a second ago, you would have heard that page caching is one of them. It's not a solution for everybody. And actually, for the presenter just a second ago, he said that page caching, they're still using it, but it doesn't quite work for them. That could be the case for you. It might not be. Could be that your application is perfectly suited to page caching. It really all depends. What it depends on is how dynamic your web pages are. If you've got relatively well-designed pages, they're much easier to cache than otherwise. If you've got a lot of content which changes regularly, of course, it's then quite difficult to cache. But generally, it's possible to get big benefits if you can cache with a full page cache. Main reason, if you get a hit on a full page cache, your PHP engine has no work to do whatsoever. Your database has got no work to do whatsoever. So that's one page request that you don't need to worry about in your general architecture. So it's a very powerful tool. Problem is it can sometimes not be used. So this is an example that I just pulled out of our website, actually. This is If you have an account at Zend, if you log in, this is what you're going to see. And this is, the Zend website is actually a good example of how you can and cannot use full page caching. This is, of course, the one page that is relatively uncacheable because you have the big red box at the bottom left there. That is my personal data. So you cannot provide that personal data out to someone else. So this page cannot really be cached. This is the one unique page. I don't have an example of all the others, but the good thing about this site design, if you look at the top left, if you can read it, it's very small font. But the difference between a logged in and a logged out user on the Zend website is one word. So you have log in if you're not logged in and log out if you're logged in. There's nothing which says, welcome Eric Ritchie. It's, of course, not so friendly, but it's excellent for page caching because you only need to keep 2 copies of every individual page for the entire website. Then you can cache absolutely everything. If you have customized information, so like a shopping basket, which is shown in the top corner, or just simply hello, so-and-so, it's not impossible to page cache it, but it makes it more difficult. Just so that you can see, the configuration of the page cache is relatively simple, but it's based upon URL. So you specify either a regex or a unique or complete URL which you're wanting to cache. You can add other conditions. The one powerful thing about the Zend page cache, as opposed to using a reverse proxy like Varnish, is that you can actually introspect the PHP session. So if you've got some key in your PHP session which identifies your user as a logged-in user, then you can use that with the Zend page cache where you can't use that with Varnish. So Varnish, you would have a much harder time. Caching that page would be possible. Of course, Varnish is very configurable. You can make callbacks against the web server, but then you are adding traffic for caching purposes, which sort of defeats the purpose. Here, you can directly access the session, and you can get the benefits of page caching without having to add extra load to the server. If you can't do page caching, it's possible. It might be the case that you don't want to do it for the reasons, for actually a variety of reasons, but the list is too long to go into. You might be able to use data caching. What data caching does, of course, is it protects, or it's trying to protect the data layer. So a database or a web service, which can be slow. I mean, of course, if you've got a large number of web front ends, accessing a single database, that database is going to be a busy machine. And it's much harder to scale a database than it is to scale a web application, because you're on RightScale or Amazon, you can spin up as many instances as you like, but the database is just technologically harder to scale. You can go to Oracle and you can get yourself an Oracle rack, throw lots of money at the problem, and of course then you can scale as much as you want. But if you don't have that budget, then things tend to get a little bit more difficult. Just check the time, okay. And then you can start to use data caching. Now the good thing about data caching is that it's relatively useful. You can prevent having to use or repetitively access your data source, repetitively access a web service. But again, that has the limitation that the data that you're retrieving has to be relatively static. So if you've got a request which is made for the index page, which is going to be different for every user of your website, then you're going to have a hard time data caching. But if you can do it, it's great. That actually does take a lot of load off your web server, if you can do it. So this is one way that you could set up a data cache. And it's actually, the way that it's a method that I see a lot as a consultant, and it is very powerful. Don't get me wrong, I've got nothing against memcache, but I tend to suggest a different way. But this is what you'll see very commonly. So you'll have a server farm with a load balancer, of course, some database servers that you're wanting to protect somehow, and then a single or cluster of cache servers. Now, the advantage there is that it's a relatively easy to maintain architecture. So you've got an application which just needs to worry about one cache. Doesn't have to worry about a multitude of caches. So it's very easy to maintain. So you don't need to worry about where the cache data is. You know where it is. It's in one place. The disadvantage is that it can be a single point of failure. Of course, the main goal of running a cache is that you increase the performance of your application from good to excellent. But unfortunately, the realities of life is that caching is usually used these days to raise the performance from absolutely terrible to something which is acceptable. It's a sad fact, but it's the way it usually goes. So if you end up in a situation where you have to kill that cache or it disappears, then the performance of your web server is going to take a nosedive. Or it's not the web server, usually it's the database. So to my mind, it's a nice, easy system to maintain, and because of that, people usually do it. But I would suggest it's not the best way to go. So this is the way that I would suggest. You're all perfectly free to disagree. But I would say get rid of that central cache server and move the cache onto each of the web nodes. Thing about this, or the advantage is that you then have a copy-paste architecture. So you need more web servers, no problem. Just throw a couple hundred extra web servers in there. You've got a couple hundred extra caches. If one machine goes down, that cache is lost, but who cares? The machine that was accessing it is also gone. So it's no problem. You don't then have the issue of, oh, my cache has disappeared. You don't have the issue of accessing your data via TCP/IP. There's nothing wrong with TCP/IP, it's a great thing. But there are limitations. The number of sockets which are available to machines which are connecting to that cache or the cache machine itself are limited. It's usually somewhere configurable between 30,000 and 60,000. So if you've got large numbers of servers with large numbers of Apaches all talking to that cache, you'll eventually run out of sockets. Now, for most people, that's not a problem. But when you get into a high scalable architecture, that can be a problem. It has been a problem for one of my customers. They eventually not only couldn't talk to the cache, but the web server was no longer reachable because there was no remaining TCP/IP socket for customers to talk to that web server. So if you don't use TCP/IP, the problem is 50% better because each Apache only has the incoming connections to deal with. Of course, you can recycle the connections faster, but this is not an out-of-the-box situation. So you can go in, if you're a good sysop, and tune all these preferences, but why bother when just using a shared memory cache will solve the issue? So a shared memory cache is Zend data cache. Like I say, it's not something that you get for free. The disadvantage is that you've now got X caches to maintain, not just one. So you've got to do a bit more work. So it's not the path of least resistance, but what I tend to suggest, or what I tend to use as an analogy, so if you're standing at the top of a mountain, you've got a 1,000-foot drop at your feet. The easiest way to get down there is to jump. That's the path of least resistance. But it's going to be a bit painful when you reach the bottom. It's much easier to walk down the path. It's going to take you longer. It's going to be a bit more effort, but it's not going to hurt as much. Same thing with caching. Do a little bit more work, and you'll see the rewards. Just a little bit about Zend data cache. I'm just going to skip through these slides because I don't think we've got the time for them, because I've got another 20 slides to get through. I want to talk about those. But it's relatively easy to use. So if you've got the Zend data cache enabled, you've just got a PHP API, which is available to you. And then you can, of course, insert data into the cache, remove data, or pull data out of the cache. And this is all working in shared memory. So it's attached physically to your Apache. There's no communication time. It's just directly there. So instead of having to wait, admittedly, a relatively small amount of time to get your data out of Memcache, you're now talking about pretty much instant access to your cache data. It must be said that usually when you're looking at performance statistics for memcache, they'll look very impressive. The reason why they're very impressive is because the memcache was running on the machine that was also running the web server. That's not usually what happens in real life. So there's always going to be some latency accessing a network cache, whereas if you've got a shared memory cache, much faster. Okay, so mentioned it's not the path of least resistance, but it is possible to reduce the amount of effort that you have to do to maintain that cache. The way that I tend to do it, or the way that I would suggest that you do it, especially if you have access to Zend Server. Of course, you don't need to use Zend Server. There are other open source drop-in replacements for these things. So you can use a job queue to maintain your cache. Zend Server has a distributed job queue, and you can register jobs which will execute on each of your front-end servers. And so each one of those jobs is just a very quick kill in the cache. So if you need to update a cache, then just delete it, and then it will automatically repopulate. But then you've got the problem, okay, I've got a scalable architecture, and yesterday I had 100 servers in that architecture. Today, I'm not too sure. Is my load higher or is it lower? I don't know. So how many servers do I have to actually go and talk to? Difficult to say. Well, the way that you can say is that you can ask Zend Server, because Zend Server knows exactly how many nodes are in its cluster at any one time. So you can make a web API call to Zend Server, get back a list of servers. Then you can just schedule a job for each of those servers to update that cache. So in actual fact, the amount of code that you have to maintain to effectively have such a distributed cache is very small. How small? It's that small. It's a bit of a lie, because the web API call is not in there. But in essence, that's the amount of code that I needed to write to maintain my cache. The bit at the top, that's the piece of code which is registering my jobs in a loop. The bit at the bottom is the job which actually executes. So you can imagine that that piece of PHP code is going to execute pretty quickly. So we don't have a large delay waiting for our cache to be maintained. It's actually very, very fast. Now, what I didn't show was the web API call. It's just a RESTful call. So it's nothing that is hard to achieve. It just requires a little bit more code than I could fit onto a slide, but it's about 60 lines of code. So in addition to this, you've got another 60 lines, but that's not bad, really. Now, if you want to make things even better, because the biggest problem with running a cache is what happens when you decache. So your database is updated, you know this, you kill one of your keys, or maybe even if you're really unlucky, the entire cache. What happens then is that your 200 front-end servers start to hurt your database very bad, because they're all trying to update the same record in your cache. So what you can do is, just with a little simple change, is pre-generate that cache data. So instead of sending out a job which says, okay, here's a key, please remove it from my cache, you can now say, here's a key, and here's a new block of data. Please insert this data into my cache at this key. So instead of having to wait for all the front-end servers to do your job for you, you can effectively maintain your cache very, very fast. The benefits of that is that your back-end server, or your database, now only sees one request. It doesn't see 200 simultaneous requests for the same data. Very, very nice. Okay. So that's about what I'm going to say on caching. It's a relatively mundane topic, but going to go into something a little bit more interesting. How many people here know the job queue or use a job queue? Okay, 1, 2. 3, 4? Okay. Thing about a job queue is it has so many different uses, it's a bit hard to visualize them. Mostly you use a job queue, or you can use a job queue to replace cron. And a lot of people that I talk to use job queues for exactly that purpose. That's just one use. That's actually the least suited use for a job queue. A job queue, its basic design is to try and break a relatively sluggish component of an application workflow out and run it as a separate asynchronous job. So, one example of that is this slide, which might be a little bit hard for some people to read, I hope not. So on the left-hand side, you have probably the traditional architecture for a blog or a wiki. So you've got a user that posts some information into the blog, gets written into the database. Perhaps the site index gets updated somehow. Maybe we send some emails out to administrative users asking them to go off and moderate that post, make sure that there was nothing offensive written in there. And we would also maybe update an RSS feed. And of course, finally then, say thank you to the user for posting. That can take quite a lot of time to execute through. If we were to take those three gray boxes and separate those out into an asynchronous job, we can return control to the user very quickly. And although we're still doing the work in the background, so our web server is doing the same amount of work that it always did, but as far as the user is concerned, your application is now 3 times faster. So it's really marketing. You're really doing a lot of work that you always were doing, but the user is now not waiting for it to happen. So a job queue can be very useful, depending on your website, of course. It really depends if you have such a sluggish component that you can break out. But in essence, can be very, very useful. The other good thing, of course, about the job queue is that you have hooks into event monitoring. So if there's something which is going wrong with your jobs, you'll find out about it very quickly. You can have Zend Server send you an email. If you've got someone who's looking through the event list, they'll see it very quickly. And it's just much more convenient than using background jobs. You can quite happily, of course, in PHP, exec a shell script which is going to run off in the background, but then you've got absolutely no visibility over it. Might work, might not. Because it's an exec, it's going to work slowly. So possible, but not so good. With a job queue, you've got visibility over everything that your server is doing. And the other good thing about the job queue is that you can delay jobs. So if you've got something which has to happen, but maybe it doesn't have to happen right now, maybe you can wait until a particular peak period is over before that job runs, then again, you're going to get benefits. The other thing is that you don't need to run that job on the server that schedules the job. It can run anywhere. So you can have dedicated servers specifically for the purposes of running your background jobs. This is very important if you're doing things like video conversions. You don't want to be running those on your front-end servers because that's going to seriously load down your application server, and it's going to really look bad for your end users. Okay. How do you use the job queue in Zend Server? Well, we've seen an example on a previous slide, but this is a more generic example, just 4 lines of code. And the reason why there are 4 lines of code and not 2, by the way, is that I wanted to make sure that the job queue is enabled. If you're using any Zend Server component, this is something that you should do. Make sure that it's actually there. As you never know, the administrator might decide, I'm going to turn this off today. And then your application starts displaying white pages instead of the content that you want, which is a little bit unfortunate. So I just always put checks around my code. So really, it's just a case of instantiating one class and registering a job, which is nothing more than a URL. Now, if you don't want to do what I'm doing here, pass in get parameters. Maybe your application requires, doesn't process get parameters. It's up to you. you're the one that writes the job, that's being executed, you can quite happily pass data to it another way using an array of parameters. And this is what you would do if you were pre-generating cache data. You would quite happily just pre-generate your cache data, tag it onto the bottom of this job with parameters, and then you can process that at the other side. So if we wanted to get really, really sexy, what we could do is delay our jobs. And not only that, we can name them. The benefit of naming a job is that you can check up on it later, generically. Of course, you always, when you register a job, get back a job ID, but that's just a number. And that's an incrementing number. So it's not tremendously meaningful. But what you can do is you can say, okay, this job is of type, is of class. In this particular case, I think I went for indexer. So here's my indexer job, and I'm going to want to start it actually 5 minutes in the future. Now, let's say, for example, this is a blog, and it's a very highly frequented blog, and we want to index, of course, every page or every new submission which is coming into our website. Then we've got to do a lot of indexing. But this way, I say, okay, I've got a new submission. I'm going to index in 5 minutes' time. Then the next user comes along and posts 30 seconds later. I can now check in my job queue and see, oh, I've already got an index job, so I don't need to run another one. So I can simply skip that step and return back control to the user. Of course, if you're getting a post more often than every 30 seconds, you can imagine that this will reduce the amount of load on your server quite radically. All, like I say, depends on what your website is doing, but I think you can see the benefit here. This is the code that you would use to just query a job. Again, relatively straightforward. In this particular case, you've got a job which you've executed. Maybe it's executed, maybe it hasn't. So you can work out, first of all, if it has run. If it has run, you can work out what its output was. So you can get back its output, up to a limit, of course. So if it's maybe going off and trying to build up something for you, you can get the return value of that job. Or if it's just status information that you're wanting to give back to the user and maybe a message window, that you can do as well. This is just for the sake of completion, the other end of what I was saying earlier. So if I've got a job which is scheduled 5 minutes into the future, I can see if it's run or not using this code. So I can just put together a little bit flag saying, okay, I want to see if there are any pending or scheduled jobs, and of the name indexer, or of the name indexer. If I get back any response, then I know something's there, and I can then not bother registering the next job. Otherwise, I can go on and do just that. Okay. This is actually a pair of slides that I borrowed from one of my colleagues because he made a good point, so I decided to add them in. So if Jan's hiding in the room somewhere, I'm not plagiarizing your work, honest. His point was that caching is great, and using the job queue is great, and all of these things that I'm talking about today are great, and if I didn't press the wrong button, that wouldn't have happened. But they should only be used if needed. PHP applications are not generically slow. Web servers these days are pretty high performance beasts. They have lots of processor power, they've got lots of memory. So what you should do is finish your application development first. Don't waste time thinking about performance until you're at the end of your application development cycle. Then look to see if you've got issues. Take steps as soon as you know that you've got a problem, not before, because you might be wasting your time. In fact, you probably will be wasting your time, because it's difficult to predict. Well, okay, let me say it's impossible to predict where performance problems are going to arrive from until you're actually at that point. Until you're running those servers, you're load testing them, you're starting to see real life conditions. you're not going to be able to tell where your performance problems are. So develop first, check, take steps. Don't waste your time. So the one thing which probably occurs very frequently to people when they're developing PHP applications, that it's more of a problem for system administrators, is disk I/O. The funny thing about disk I/O is it's the one modern weakness of a web server. Over the last 10 years, web servers have become so powerful that we don't really need to worry about processing power anymore. We don't really need to worry about how much memory we have anymore. If we're looking for every last millisecond, sure. But most people aren't interested in millisecond optimizations. They're looking for 100, 200, 300 millisecond optimizations. But the one thing which is definitely going to kill you first in a web server is disk I/O. Because hard disks, they've got faster, sure, but only marginally faster than they used to be, because there's a physical limitation of shuffling that much data onto effectively a piece of rust. Of course, you can use SSDs, but they only help so much as well. So this is the first thing that I would tend to look at if I'm experiencing a performance problem, what's going on with my disk I/O. You can do a lot without any real pain to reduce the amount of disk I/O which is going on in your system. The one thing is, of course, using an optimizer or an opcode cache. It doesn't have to be Zend's optimizer. You can use APC. You can use anything you like, but just use one. Because these days, modern PHP applications, they tend to be distributed over hundreds, maybe thousands of files, especially if you're using a framework or if you're using multiple frameworks. Because they generally tend to be designed in an object-oriented way, which is nothing wrong with that. Again, nothing against object orientation, but it has the side effect that you're dealing with one class per file, and then you've got a lot of files. These all have to be read from the hard disk. They need to be compiled and before they get executed. So why do that multiple times? Use an opcode cache. Everything is then held in shared memory, and things tend to go a lot quicker, especially if you're working under Windows. Windows has a relatively hard time working with disk I/O. Linux is a little bit more sophisticated, but it still, of course, could do with not having to repeatedly load files. Okay. Now, the thing is that you might not notice tremendous benefits from using an opcode cache, especially if a lot of your performance problems are database related, but it still will bring a benefit. And the biggest benefit, of course, is that your hard disk won't melt. Static files. In my opinion, they really should not be on a web server that is running PHP, because it's not what your web server is good at. Your web server is good at producing dynamic content, talking to databases. So why are you hosting PDFs, images, CSS on that server? There are so many different solutions that, it's hard to list. I've only mentioned the one. But you can use a CDN. You can have a separate server farm which is hosting static content. The advantage of doing that, if you have a separate architecture for your static content, if you find that your performance problems are actually coming from serving out static files, then you just grow that one part of your server farm. You don't need to add extra dynamic capacity when you don't need it, and vice versa. So if you're having a problem processing XML files, it's using up a lot of your time, then you don't need to add extra static serving content capacity when you don't need it. If you really must use local storage, think about using a RAM disk. Of course, you need to initialize it every time the machine boots, but it's not really too hard to do so. RAM is usually cheap. So long as we're not talking about terabytes of PDFs here, Should be no problem. Logging. PHP will produce a huge amount of log information if you just run it stock. The standard PHP info file will turn on warnings and notices. And warnings and notices are great, but you really don't want to see them in production because they're usually things along the lines of, this variable has not been initialized. Yeah, okay, so what? This is PHP. This is not Java. We don't care. We'll use a variable which is not initialized. It doesn't bother us. But it'll still be logged onto the hard disk, and that will actually cause throughput on your disk I/O. So make sure that you have such an error mask in your PHP info. You're only really caring about errors. And if you're using Zend Server, you'll find out about these errors through event monitoring. So if you're using Zend Server, turn off error logging altogether because you don't need the information. It's in Zend Server. You don't need it in two places. And Zend Server itself, of course, has logs. There are very few occasions that Zend Server has problems, but sometimes it happens. And so the logs are there for that purpose so that support can come and help you. But if you don't have a specific problem with your server, turn down the logging levels of all the Zend Server components. This will reduce the amount of disk I/O that you have. Bless you. Controversial point. I dislike X3. X3 is a nice file system if you're running a database. But if you're not, if you're running an application server, it's a disaster. Reason is X3 loves large files. It does not like large numbers of small files. The performance is abysmal. If you don't believe me, test it out. RiserFS, which nobody loves because the poor guy who invented it, well, had a bit of an unfortunate exchange with his wife and ended up in prison. One of those things. But RiserFS is 20 times faster at serving out small files, large quantities of them, than X3. 20 times. Even XFS is 2.5 times faster. And yet, X3 or X4 these days is the default file system that you get when you install Linux. And who changes it? It's fun, but there you go. So if you're using Ubuntu, if you're lucky enough to use Ubuntu, you can install RiserFS off the bat. Problem is, if you're using an enterprise Linux or Red Hat or SUSE, they don't support RiserFS anymore, which is a pity because it's a terrific file system for web service. It has the unfortunate side effect of, losing some files occasionally, but given the fact that this is a web server, who cares? You just destroy the machine and rebuild it. It's hardly ever happened to me, by the way. The other thing that I hear quite often is, oh yeah, I've got an NFS server and it's working great. It's tremendous performance. Yeah, right. Tremendous performance when you're not loaded. Well, as soon as you start to get lots of load on that NFS server, the whole thing nosedives. So, use local files. Don't ever use a network file system. Other thing, distributed file systems, they sound great, they're very sexy. The problem is that they scale terribly. If you've got 2 or 3 servers, no problem. If you've got more than 2 or 3 servers, or if you've got 10, 15, 20, better have a really, really fast network connection behind that. And better not be wanting to do anything else with it other than the distributed file system. And PHP, of course, uses your network. It is going to be making web service calls. It's going to be talking to databases, so on and so forth. And yes, of course, that's network traffic. Yeah, okay, fair enough. So if you've got a network congestion problem, if you happen to be running with a relatively slow copper link behind that computer, you may have a problem. It's not necessarily going to be an issue because most people generally don't have an issue with network, but it might be something that you want to consider. So just try and work out how much data you're trying to send across that network link. try and work out if it is something that could be an issue. So that would be it. Anybody got any questions? I think I'm a little bit early for questions, but okay, just gives you more of a chance, or you can go and have more of lunch. I think it is, no, it isn't lunchtime, good grief. You can go to the next session early. Anybody got, oh, okay, if you could just come to the mic so that we can hear you.
Eric, have you used Zend page cache along with any techniques that allow you to have a small amount of dynamic data on the page?
Yes, it is possible. What you can do is, well, with the example that I actually showed, what you can do is just load the skeleton page and then update the personal details using an AJAX call. It's something that you should maybe use a bit sparingly. So it shouldn't be used in all cases because that AJAX call is, of course, going to add load to your server as well. And depending on the network latency between your client and you, could make your website look a little bit bad because, of course, it has to get this data and populate it dynamically. So it might look like there's a big hole in your website and then suddenly it appears. But it is possible to do that. If you're very good with JavaScript, you might want to try fetching data for other pages which the user could click into the browser space and then populate things very magically. Don't ask me how. I'm a server guy. I don't do JavaScript. But I'm sure there are people, excuse me, people who could help you. Well, that's one possible way to actually use page caching at all times. But be careful with it because AJAX calls are very sexy and very Web 2.0 and all that, but they can cause problems. What happens if you get a disconnect? You're going to have missing data on your page. But it is something that you might want to consider. Yeah?
Regarding the job query function, if we have a job that uses environment information or session information, does we need to pass that through the parameters?
Yes, you will need to pass it through the parameters because the job queue job is a completely separate job. So I can put this down now, apparently, because it's a separate web request, potentially to your application server, but it doesn't have to be to your specific application server. It could be to any other server. And of course, if it's to another server, you have no session anyway. So any information that you want to pass to that job so that it can do its work has to be passed as parameters. Any other questions? Yep.
Okay, one more. I saw in Zend Server's performance tooling, there was a way to determine what the breakdown of performance was, like database calls or other things. When you say database calls, that mean MySQL, or how does the Zend Server know what the database call is?
It knows what the database call is because you're calling a specific PHP function. So if you're making a request to a MySQL function, or a PDO MySQL, or a PDO Oracle, or the OCI, then it will consider that to be a database performance or database time slot.
There are particular functions that Zend Server knows about, like if I use DB2, will it know? Or can I add that to a list that Zend Server could recognize?
There is an event which has such a functionality, and I'm assuming that the GUI will also use that. Don't know because I don't know the Zend Server engine that well, and I'm not a Zend Server developer. But if you go to the booth, I'm sure you'll find someone who can answer that question because the devs are here. And so they'll be able to answer that question more reliably than I could.
It picks it up from the same list.
It picks it up from the same list. Okay. Thanks, Kent. It's funny, I thought Kent was going to ask me a question. I was getting all worried there. Anybody else? I think we've got, 8 minutes left.
Just regarding the optimizer, do you have any information regarding if its work have better performance than other opcode caches or just the same?
Apparently, mileage varies based upon what we heard on the today's keynote. But in our experience, and I think I heard Kent talking to the gentleman this morning, asking him if he had actually talked to us about the performance problems they were having. But usually, the opcode cache will give you better performance than APC because it's not just an opcode cache. It's also an optimizer. So if you've ever used GCC before, there are a large collection of flags that you can pass to the compiler to get it to perform optimization passes on your C code. The same thing happens with Optimizer Plus in PHP. So it will, first of all, try and go through your PHP code, see if there are some subtle optimizations that can be performed to make things faster. So of course, PHP code is written by humans. Humans tend to like to see nice, neat, readable PHP code. That's the whole maintainability thing. Don't understand it myself. And so that's usually very good for your colleague who has to read your code, but it's not so good for the compiler or the executor. So the optimizer does a little bit of extra work, makes things a little bit less readable, but faster. Admittedly, the performance gain that you're going to get from that is about 1%, but every 1% counts, I suppose you could say. In the real world, you're not going to notice a difference. If you've got a lot of database calls, those are the ones that are going to hurt you. It's not the compilation of PHP which is going to be significant. But anything is possible. Any last questions? No? Great. Okay, thanks a lot for coming.